Alrighty, today on the Wolken Way, we are working on 4.4, which is trigonometric functions of any angle. Yesterday, we learned that we were able to do trig functions and special triangles in quadrant 1, which is right here. And then I've also drawn this in right here, and we'll talk about that in a second. So this little acronym that I'm going to give you is ASTC. It stands for All Students Take Calculus. And you can see those are the first letters of that word right there. So what the heck is it for? So just so you know, we're going to start off by saying that when you draw a triangle or an angle, R is positive in all four quadrants. So R is always going to be positive. If it's on the unit circle, we can say R is 1. But we're not going to be only on the unit circle in today's. So the next thing we're going to talk about is what sign each one will take on in each quadrant. So yesterday we learned that we have these ratios now. Before in geometry, you didn't really superimpose your triangles on a coordinate plane, this rectangular plane, but we do that a lot in pre-cal and in algebra 2, so we expand our knowledge of the trig ratios to these ones. So really emphasizing sine goes with y and cosine goes with x. That's super important. So if sine is y over r, if you look at this right here, this would be the x is positive and the y is positive, because that's true in quadrant 1. So if I'm in quadrant 1, then I'm going to have a positive number from the y value here divided by a positive value, because r is always positive, and a positive divided by a positive is positive. So let's move on to cosine in quadrant 1. I will get a positive divided by a positive, which is a positive, and then over here I'm going to get a positive divided by a positive, which is a positive. So all three of these ratios, no matter what numbers I'm using, because in quadrant 1 x and y are both positive, all trig functions are positive in quadrant 1. And this works for the reciprocals of these as well. In quadrant 2, when I go to do sine, sine goes with the y value, so it's going to be a positive over a positive again. So sine is positive. When I go to do cosine, notice any x values in quadrant 2, because we had to go to the left, are negative. So that's a negative divided by a positive, which is a negative. And then when I go to do tangent, it's y over x, and I also get a negative. So if you see that, all were positive in quadrant 1, but only sine is positive in quadrant 2, and that's why it's an S. So the All Students Take Calculus acronym represents where trig functions are positive. And again, cosecant is also positive here since it's sine's reciprocal. So we'll go into quadrant 3 just to see it a little bit more. This is a T, so we're expecting tangent to be positive, and that seems a little strange, but let's look here. Y over r would be negative over positive, because the ratio is the radius is always positive, so that equals a negative. And then cosine is also negative over a positive, which is a negative. But when I come over here to do tangent, a negative divided by a negative equals a positive, and that's why tangent is positive there. And the same thing happens where cosine is actually going to be positive in quadrant 4. So let me just remind you, this is quadrant 1, quadrant 2, quadrant 3, and this bottom one is quadrant 4. So how are we going to use this? This first piece right here says if the sine of the angle is less than 0. So that's just letting us know that the y is negative. So the y values are negative. And then this one right here says, oh hey, cosine is also negative. So before we get to the cosine one, I just want you to look at this. The y values are negative. Y values are negative happen down there, because that's where the y is negative, below the x-axis. So that's quadrant 3 and quadrant 4. Notice this only says name the quadrant, so it can't be both of these. So they actually had to give us a second condition, and they tell us that the x values are also negative. And the reason why they're saying that without really saying that is that you are supposed to know at this point that cosine goes with x. So you should know that if it says cosine, it means the x values are negative, which happens in quadrant 2 and quadrant 3. So where are both conditions met? In quadrant 2. That's actually quadrant 3. I'm bringing my A game today, apparently. Okay, moving on. So now we are going to get off of just quadrant 1, and we're going to go to quadrant 2, 3, and 4. We're going to do positive angles, negative angles, and so here's just some steps that you should remember. First of all, draw the angle. Then you're going to make the triangle with the terminal side of the angle and the x-axis. Super important that you do the x-axis. Then you're going to get the reference angle. The reference angle is going to give you, if we can do it without a calculator, either a 30, 60 degree reference angle or a 45 degree reference angle. So those special triangle ratios we learned yesterday are so important. So just keep in mind, I'm going to write them, kind of cram them up here. 1/2 root 3 over 2 and 1, 30, 60, 90. So 1/2 is always opposite 30 degrees and root 3 over 2 is opposite 60. And then for the 45, 45, 90, we have root 2 over 2, root 2 over 2, and 1. So those are the angles, the ratios that goes with the angles that we're going to be working with, because we're not on the unit, we're on the unit circle. Once you found your reference angle, make sure you label your triangle and or point. So there's two different methods that you can do for this. It's up to you which one you want. Then you're going to evaluate using whatever trig function it tells you to do, and then I want you to check your signs with all students take calculus. So the sine of 300 degrees, I'm going to draw a 300 degree angle, so 90, 180, 270, 30 degrees past. So this said to draw the angle and then make the triangle with the x-axis and then label your reference angle. So if I went 30 degrees past, that is the reference angle, the terminal side and the x-axis. Next thing is to label the triangle with your special ratio. So opposite 60 is root 3 over 2, which means this hypotenuse or radius is always 1, and then this right here is 1/2. But keep in mind, because this length of the triangle is down, this is actually going to be negative root 3 over 2. So some people take it a step further just for their own understanding, and they write a point. So when it says and or point, some people just do the point and some people will do both. So that's not even what we're asked to, we're not even done yet. The sine of 300, so sine is y over r. So we're going to take the y value. So this is really easy to see from the point. The y value is negative root 3 over 2. Or you can choose the height of that triangle, whether it's going down or up. That's negative root 3 over 2, and the radius is always 1, so this is negative root 3 over 2. Now, should sine be negative in quadrant 4? Well, all students take calculus. Only cosine is positive, so yes, sine should be negative. You want to double check that. If you label your sides appropriately, then that shouldn't be an issue for you, but a lot of students just go really fast and label their reference triangle. So if that's you, then all students take calculus. It can be super helpful for you to not miss points. Tangent of 5 pi over 4, that's 1 1/4 of pi. That's going to bisect quadrant 3. The reference angle is going to be 45 degrees or pi over 4. If it's the reference angle and I'm not asking you specifically for the reference angle, it's fine to go ahead and convert it back to degrees. This is root 2 over 2, but because I went to the left, it's negative, and this is negative 2 root 2. Tangent is y over x, so I get negative root 2 over 2 over negative root 2 over 2. Negative divided by a negative is a positive, and in fact it's positive 1. So this says right here, all students take. So I ended up in quadrant 4. My angle's in quadrant 4. I'm taking a tangent, so that should be positive there. I'm just going to go ahead and work the rest of these the same way, and then you can just check your answers. So 17 pi over 6, 6 pi over 6, 12 pi over 6. That would be 18 pi over 6, so I'm not quite there. I'm a sixth away, so there's my little sliver. If I'm a sixth away, it's a 30-degree reference angle. This is 1/2, negative root 3 over 2, and 1. If you want to label the point, feel free to do so. That would be negative root 3 over 2, comma 1/2. Cosine is x over r, so it's negative root 3 over 2 over 1, which is negative root 3 over 2. And all students, that's an S, only sign is positive, so the cosine should be negative. Okay, moving on, negative pi over 6 is going to be here. It's secant, which goes with cosine. So since it's a little sliver, it's a 30-degree angle. Negative 1/2, root 3 over 2. And then secant is going to be r over x, which is going to be 1 over root 3 over 2, which is going to be 1 over 1 times 2 over root 3, because I'm going to copy dot flip, which is going to be rationalized, so I get 2 root 3 over 3. This one, cosecant of 180, just wanted to throw in there as a refresher from yesterday. Here's 180 degrees. You're not going to be able to make a triangle on a quadrantal, so label the point. Cosecant is going to be what? It's going to be r over y. The radius is always 1. And the y value here is 0, so this is going to be undefined. This one right here, ooh, this is a lot of rotating. 3, 6, 9, 12, 15, 18, 21, and 23. It's a third, so it's not a little sliver. It's going to be like that right there. It's a 60-degree reference angle, negative 1/2 in the x direction, and 1. Sine is y over r, root 3 over 2 over 1, which equals root 3 over 2. Okay, ooh, I didn't really show you guys that. Let me push that up so you can pause it and take a look at some of that work. Okay, now we're going to be working on the last 2 examples, and these are ones where you are not specifically on the unit circle, and we'll get to that in just a second. Okay, so here we're evaluating trigonometric functions that are not on the unit circle. So what this means is that we cannot necessarily rely on our trig ratios that we know from 30, 60, 90 or 45, 45, 90. So what you're going to want to do is actually draw out whatever they give you. So when in doubt, draw it out. So let P be a point on the terminal side of theta, and it's the point 1, negative 3. So the x is positive and the y is negative. So you're going to go 1 and then negative 3. So here is theta. Probably did something like that. We actually don't need to know theta to be able to find the 6 trig functions, because when we write the 6 trig functions, it doesn't come out to where you need that. You write this. The sine of theta equals, the cosine of theta equals, and the tangent of theta. So you don't actually need to know what theta is to be able to do this. It's kind of like backwards of what we were doing before a little bit. We do need to find the radius, since sine is y over r, cosine is x over r, and tangent is y over x. So we're going to go ahead and use good old Pythagorean theorem. 1 squared plus negative 3 squared equals c squared. 1 plus 9 equals c squared. If you want to change that to r squared, that totally works. So c squared equals 10. So c equals plus or minus root 10, but we know the radius is positive as defined by mathematicians, then that's just going to be root 10. So now that we know this is root 10, we can just do this. Sine is going to be negative 3 over root 10. Going to rationalize and get root 10 over 10, which is negative 3 root 10 over 10. I kind of ran out of room right here, but I want to say what would cosecant theta be? I'm going to flip this fraction, but if I just flip this one, I'm going to have to re-rationalize. So I'm going to go to the original one I got before I rationalized and just flip that. And remember what I said before, it's not typical for mathematicians to put the negative in the denominator. So when you flip that fraction, you either tag it with the numerator or you're going to go ahead and put it right next to the fraction bar. Cosine is going to be 1 over root 10. And then when I rationalize that, that's going to be root 10 over 10. So then the secant of theta is just going to be root 10 over 1, which is root 10. Let me get my answers boxed here so they don't get lost. Don't mind my protector dog, Layla. She is, here's something outside. Okay, y over x is going to be negative 3 over 1, which is just negative 3. And then to find cotangent theta, I flip that and I get negative 1/3. So that's not bad, right? I mean, pretty straightforward. All right. So now we are moving on to the very last example. Given that the tangent of theta equals negative 1/3 and that the cosine of theta is less than 0, so we're just reminding ourselves that the x values are going to be negative. Find the sine of theta. So first of all, we're going to look at this. Okay, so if we know that the cosine is less than 0 and the x values are negative, we know we are either in quadrant 2 or quadrant 3. And then we have this right here, and tangent's ratio is y over x, and you see how the negative is tucked with the fraction bar. So our choices are either this or our choice is that. So which one is it? Well, if the x was positive, which would be this case, then we would be somewhere over here. So it can't be that case. So the y is going to be 1 and the x is going to be negative 3. So it's going to be right there. Similar to the last one we did. So since we already did the Pythagorean theorem on that, we know that that's the square root of 10. And all it's asking us to do is to find sine theta, which is y over r, and secant theta, which is r over x. So now that we have a complete triangle, we can find that. So y, 1 over root 10, and then when we rationalize that, that's root 10 over 10. And then over here we have r, which is root 10 over x, which is negative 3, so negative root 10 over 3. And that's it.